Hello, this is part B of the Chapter 8 lesson. In part A, we talked about sample size and how it relates to calculating confidence intervals. In this part, we're going to start talking about sample size and how it relates to hypothesis testing. So first, let's just kind of start off with a brief review of what we do in hypothesis testing. So we start off with choosing a significance level that we call alpha. Typically we use alpha equals 0.05, but we could use other values. And then we have an associated number called the confidence level, which is simply 100 times 1 minus alpha %. And then in the end we calculate a p-value, and we compare that p-value to alpha. If the p-value is less than alpha, then we reject the null hypothesis. Otherwise, we do not reject the null hypothesis. Now, a confidence level, this is the same term that we used when we did confidence intervals. In part A, we talked about what that confidence level means there. But here in hypothesis testing, we want to ask the question, what does the significance level mean? What does this number alpha mean? What does it mean that alpha equals 0.05 and that we work at a 95% confidence level? So just what exactly does that mean? So that's the first question that we're going to try to answer here. And so to try to start to answer this question, let's look at this hypothetical scenario that we looked at in part A of the lesson. Suppose that in the population of all people, systolic blood pressures have a mean of 125 and a standard deviation of 15. Now let's suppose that for some reason we suspect that mu is not equal to 125 and choose to test that suspicion with a hypothesis test. So like in part A, we're going to pretend that we don't know the value of mu, and then for whatever reason we suspect that mu is not equal to 125, and we're going to try to test that claim with a hypothesis test. And so our hypotheses for this test would be the null is that mu equals 125, and the alternative is that mu is not equal to 125. And this statement here is the same as our claim, and the null hypothesis is always the statement that mu equals a number, and so these are our hypotheses. Now let's make an observation here. This null hypothesis is a true statement. How do we know it's true? Well, because we're told right here in the problem that in our population mu is equal to 125. Now down here we're pretending that we don't know it and we're claiming this, but in reality mu or h naught is a true statement. Now why is that significant? Well, remember when we talked about hypothesis testing, we said that all of our calculations are done based on the assumption that the null hypothesis is a true statement. Now sometimes that assumption is correct, sometimes it's not. In this case, that assumption is correct. Okay? So again, our null hypothesis is a true statement. So when we calculate the p-value, we're either going to reject the null hypothesis or not reject it. If we reject the null hypothesis, we're saying that that statement is probably false. Whereas if we do not reject it, we're saying that it could be true. Well, in this case, it is a true statement, so we do not want to reject the null hypothesis. So we should not reject the null hypothesis. That should be the conclusion that we come to. But as we'll see here in a bit, we're not always going to come to that conclusion. If we were to reject the null hypothesis, this conclusion would be an error. This is what we call a type 1 error. Now the book has used this term type 1 error many times in chapter 7. This is the first time we've mentioned it. But a type 1 error is defined as the error of rejecting a true null hypothesis. If the null hypothesis really is a true statement, then we should not reject it. If we do reject it, that's an error, what we call a type 1 error. Okay. So the question is, what is the value of or what's the probability of a type 1 error, and how does that relate to the significance level? Well, to try to answer that question, let's look at the workbook chapter 8 and the worksheet HT simulation. Which stands for Hypothesis Testing Simulation. This is going to work very similar to the CI simulation that we did in Part A of this lesson. Up here we can enter our population parameters, which are 125 and 15 in this case, and then mu naught, the number in the null hypothesis. In this case that number is 125, and then over here we'll enter our significance level. Now this simulation simulates selecting a sample of 6 people, measuring the blood pressure of each. It calculates the sample mean, the sample standard deviation, and then it calculates the test statistic for our hypothesis test, and then the p-value. And then based on that p-value and the significance level, it determines do we reject the null hypothesis or do not. Well, if we look at this first sample, this is a very large p-value, so we do not reject the null hypothesis. So in this case, we came to the correct conclusion of not rejecting the null hypothesis. But in our second sample, we have different blood pressures. Here's our sample mean. Notice it's rather large. There's the sample standard deviation. Here's our test statistic. Here's the p-value. In this case, this p-value is less than 0.05, and so we do not reject the null hypothesis. So in this case, we made a type 1 error. We rejected a true null hypothesis. And so in this simulation, we do about 1,000 or 2,000 different samples. And in each one, we either reject the null hypothesis or we do not. Up here, it calculates the proportion of times that the null hypothesis was incorrectly rejected. And so in this case, we have about 5.4% of them that were rejected. And now if you hit the F9 key, you're going to do a new simulation, so all new samples, and this number here is going to change. But what we want to do is compare this number here to the significance level alpha. Now notice that they're roughly the same. And so now I want you to play with this simulation a little bit and change the values of mu and mu naught to the same value. So maybe change them both to number 130 or the number 110 or the number 150 or just whatever numbers you want. Also change the significance level. Each time you change a number, hit the F9 key several times and compare the significance level to the proportion of times that H0 was rejected. And just note what you observe. And we'll talk about those observations in the next part of this lesson.